All right, so in this video, we are going to be solving and graphing all types of inequalities, including compound inequalities, and we're going to learn a new type of notation called interval notation. Let's go ahead and get started. So let's just, for review, go through, and I want you to pause the video right now and see if you can go ahead and complete 1 and 2 on your own. Just solve for x on both of them. And then you can restart the video and I will go through it with you. Hopefully you've been able to do that. I'm going to go ahead and just go through this, review what you should have done here. As we learned yesterday, we could get rid of all the fractions in this particular problem by multiplying everything by 12. That's the least common denominator. And so I'm going to go ahead and multiply everything by 12, and when I do that, 3/4 of 12 is 9x, plus 2 times 12 is 24. 2/3 of 12 is 8x, and then 4 times 12 is 48. Then I want to get my x's on the same side, so I'll subtract 8x from both sides. 9x minus 8x is just x, plus the 24 equals 48. And if I subtract 24 from both sides, x is 24. We could check that. I think if we plug 24 in for x on this side of the equation, we're going to get that this whole thing is equal to 20. And if I plug in 24 in for this x, this side is also equal to 20. And 20 does equal 20, which means we have a correct answer. Let's go ahead and try number 2. Number 2 is a little bit different. We don't have any fractions, so we're not going to multiply by a common denominator, but I am going to simplify each side of this fraction. So here I'm going to simplify the left side by distributing the 3. This is going to give me 15x minus 21 plus 5. And then on the right-hand side, I can distribute this 4, and that's going to give me 8x plus 12 minus x. And then I can combine like terms in both sides of my equations. On the left here, I'll have 15x minus 16. And on the right, I'm going to have 8x minus x. That's 7x plus 12. Then I'm going to put both x's on the same side. So if I subtract 7x from both sides, I'll have 8x minus 16 is equal to 12. If I add 16 to both sides, I'll have 8x is equal to 28. If I divide by 8 then, let me just show this step here. If I divide by 8, one way I could write this is 28 over 8. But that's the same thing as 14 over 4, or 7 halves, which is the same thing as 3.5. And so for number 2, our solution is that x is 3.5. And you could check this. If I plug in 3.5 into the left-hand side of the equation, I think I'm going to get 36.5. And if I plug it into the right side of the equation, I will also get 36.5. And because those are equal, we know that we've done it correctly. Let's take a look at another type of problem that we worked on yesterday, and that is solving a literal equation. Here we're going to get the a in this equation by itself. The problem is that there are 2 of them. So I need those a's on the same side of the equation. So what I'm going to do first here is subtract 3a, so it's on the same side of the equation as the 8a. And if I take 8a minus 3a, that's just 5a. And then these 3a's cancel. At the same time, I'm going to subtract 5b from both sides, and I'm going to add 2c to both sides. So I'm going to subtract 5b, and I'm going to add 2c. That way, these will cancel on the left, and I'll just have 5a is equal to, and I'm going to write this as negative 5b, and then 12c plus 2c is 14c. But I want to get the a by itself, so I'm going to divide everything here by 5. There's a couple ways that I could write this, and I want you to recognize that they are all the same. I could just leave it like this, negative 5b plus 14c over 5. But if I divide both of the coefficients here by 5, I could say that this is the same thing as negative 1b plus 14/5 of a c. Another way I can write this would just simply be to say that a is equal to negative b plus, I could keep the fraction 14/5, but that's the same thing as 2.8c. All of those are correct responses. and I would accept all those. So that is number 3. Let's continue to move on. And now we're getting to some inequalities. So hopefully you remember doing some inequalities from Algebra 1. I'm going to go ahead and solve number 4 first by subtracting 6 from both sides, and then I'll get negative x is less than 9 minus 6 is 3. Then I'm going to divide by negative 1. Hopefully you remember that when you divide by a negative number or multiply by a negative number, the inequality sign is going to switch. So here we're going to have x and negative 3, but this inequality sign, which was less than, is now greater than. So I would graph this with an open circle at negative 3, and it's greater than that, so I would shade everything to the right. And I could solve the problem on the right the same way. I would subtract 1 from all 3 sides. So then I would have 6 is less than or equal to 3/5 x, which is less than 15. If I multiply everything by 5, then I would have 30 is less than or equal to 3x, which is less than 75. If I divide everything by 3, then I'm going to have 10 is less than or equal to x, which is less than 25. And if I were to graph this problem, I'd have at 10 a closed circle. At 25, I'd have an open circle, and it's less than 25 but greater than 10. There's another way that we're going to learn to write these, and that's with interval notation. Interval notation uses parentheses anytime you have an open circle and a bracket anytime you have a closed circle. And it would look something like this. Negative 3 all the way to infinity would look something like this. I'm going to start with negative 3, but it's an open circle, and I'm going to go all the way up to infinity. And because I never really get to infinity, it's a closed circle. Or it's an open circle, so it's a parenthesis. This one is actually going to look like this. I'm going to start at 10 and include 10. Then I'm going to go all the way up to 25, but it doesn't include 25. And so I'm going to have a bracket where the 10 is at and a parenthesis where the 25 is at. In Math Excel, when we do this, they'll have an open circle with a parenthesis symbol, and then they'll have brackets anytime it's supposed to be closed. So it'll look something like that. Let's take a look more specifically at what this interval notation looks like. So here you have some examples where if it's an open circle, like it is in red here and here, then I'm just using a parenthesis. Okay? But if it's a closed circle, like this one would start at 5, okay? This one would end at 5, okay, and so I have brackets. And whenever we use the infinity symbol, either negative infinity or positive infinity, it's just going to be a parenthesis because it never really reaches infinity. So this goes from 5 to infinity, but doesn't include 5. This goes from 5 to infinity and includes 5. Here we go from negative infinity to 5, doesn't include 5. Here we go from negative infinity to 5, and it includes 5. Well, let's take a look at some compound inequality situations, and that's here. All of these go from 1 to 5, but the first example does not include 1 or 5. The second example includes the 1, but not the 5. The third example doesn't include the 1, but does include the 5. And then the fourth example, they're both included. So they're closed circles. These are all AND compound inequalities. Maybe the most difficult situations are the ORs, because they all start with negative infinity and go up to a certain point, skip something, and then go to positive infinity. So for example, this first situation goes from negative infinity to 1, but doesn't include 1. Then goes from 5 to infinity, but doesn't include 5. This is a union of two sets. We could replace that with OR. Okay, you could use that big capital U, or you could just use the word OR, and that would be fine. If it includes 1, it's a bracket. If it includes 5, it's a bracket there. And if it includes both, they're both brackets. And so that's how we would use interval notation. Let's go ahead and take a look at one more question together. I want you to solve this, see if you can solve this video or this problem, and then go ahead and use interval notation to come up with what the solution should look like. And then restart the video. Hopefully you've done that. Let me go through and solve this. I'm going to solve the left-hand side by multiplying both sides by 4. And if I do that, I'll have 3x minus 3 is less than 12. If I add 3, I'll have 3x is less than 15. If I divide by 3, x is less than 5. Or, if let me just divide everything by 4 first. Here, there's other ways to do this. But if I did it that way, I'd have 2x minus 7 is greater than or equal to 13. If I add 7 to both sides, I'll have 2x is greater than or equal to 20. And if I divide by 2, I would have x is greater than or equal to 10. So it might be nice to picture what this looks like on a graph. First, we're going to go from negative infinity to 5 and have an open circle at 5, so it includes all of those numbers. Then we're going to pick it up again at 10. It includes 10, and I'm going to go to positive infinity. So in interval notation, it's going to look something like this. I'm going to go from negative infinity all the way to 5, but not include it. Then, or we could use the union symbol, the big U, or, oops, this should be a bracket here at 10, because it's going to include 10 and go all the way up to infinity, but never really reach it. And that's what interval notation looks like. That's what our homework assignment is like today. So good luck on that. We can go over questions that you have on this assignment tomorrow, and we will see you tomorrow in class.